Good afternoon, everyone. Today I'm going to be synthesizing sulfadiazine starting from acetolinide. So let's start by drawing the molecular structures for acetolinide. This is the benzene ring. Let's add a primary amine on top of that and a protected group on top of the primary amine. Let's fix it. Okay. So what first thing we're going to do, we're going to add sulfonyl chloride on the para position of the acetonilide. Let's draw the molecular structure for sulfonyl chloride. Now let's have this work a lot better. Okay, let's show what the byproduct is actually going to look like. Let's grab the sulfur. Okay, so this is what we're going to end up with. So let's show the mechanism of how this is going to occur. We're going to start by taking a copy of this, put it down here, and we'll show the mechanism. Of course, what we're going to end up doing is simply break the double bond here into an electron pair in this carbon and a positive charge on this carbon. Just put another copy here, remove the double bond and show the electron pair with its negative charge, as well as a positive charge on this carbon. Now let's show how the mechanism is going to proceed. Let's take a copy of the sulfonyl chloride. You know what? Let's just draw it once again. So, I'll get the sulfur. Okay. What's going to happen is this pair of electron is going to attack the sulfur, which is then going to break down one of the double bond into a single bond, in which we're going to end up with an intermediate product. So, and then from the intermediate product, we're going to have the chlorine atom leaving. Let's show how the mechanism is going to proceed. And we're going to show the intermediate product of what it's going to look like. Double bond here. Okay, now one of these electron pairs is going to turn this single bond into a double bond, which is then going to have one of the chlorine atoms leave. Okay, let's take a copy of this so we can show what the byproduct is going to look like. There is no need to show the electron pairs right now, because they're not participating in any reaction. Let's show this, as well as the chlorine anion with its negative charge. Its negative charges, chlorine ion. And that's how we're going to remove one of the hydrogens here so we can form a double bond here. Put the negative charge as well as the 4 electron pairs that's on the chlorine atom, the chlorine anion, let's show, so that we can remove the hydrogen and form the double bond. Okay, before we proceed anywhere else, let's actually remember to include the positive charges that are here. And let's show how this is going to break and form the double bond. Let's see. Okay, so we're going to end up with this as the final product, as well as hydrochloric acid. Okay, now let's also show the hydrochloric acid as well, plus HCl. These are going to be the final byproduct. So we're going to use this to form the next product. Copy. Let's open a new page. show step-by-step procedures. Okay, let's show the step-by-step mechanism of this as the final product. Of course, let's show this. You know what? Okay, well, show. I'm going to let's take a copy of this so we can start the mechanism. Copy, paste. Let's also take a copy of this. Let's show the electron pairs that's on the primary amines. That's the way we're going to actually remove the chlorine atom here. Let's move this a little bit up so we can show the mechanism involved. Yes, I moved it so close so that I can show the mechanism. Um, Normally I would not be showing it that way, but let's keep moving. Okay, let's use this. This is going to attack the sulfur, which is then going to break this double bond into a single bond. So we're going to show the intermediate product. Okay, let's also draw this. Copy. Let's move this sideways so that I can show so that there is enough space because this could be difficult to show. Let's move it sideways this way and move this a little bit upward. So we're going to end up with this as the byproduct. Let's show the mechanism here. The chlorine somewhere here, and let's also show negative charge on the oxygen. Before that, let's include both of the hydrogens here. There's supposed to be two hydrogen atom on the nitrogen group here. Let's try to show this. It's going to be difficult to draw both of them. Let's show it anyway. Hydrogen and hydrogen. Let's show the positive charge on the nitrogen molecule on the primary amine. See, Okay. And so how we're going to end up with the byproduct, the final product, is that one of the electron pairs on top of the oxygen atom is going to turn into a covalent bond, which is then going to remove the chlorine atom from the molecule. And the chlorine will remove. So we'll end up with pretty much the final product, close to the final product that show. Result, this. Show both hydrogen and positive charge as well in the amine, and how we're going to remove one of the hydrogen using the chlorine atom plus Cl minus. Let's add the electron pairs on the chlorine. And let's show how the covalent bond is going to break down. And one more thing is that we also have to include the positive charge that's on the nitrogen here. So we're going to end up with the final product, which is going to be this structure here, as well as hydrochloric acid. Plus HCl. Okay, now to proceed on to the next step, we're going to perform the hydrolysis on this to get the final sulfadiazine as the product. Let's take a copy. We're going to take a copy of this. Actually, we already have a copy. We're going to open a new page and show how the mechanism is going to work out. Okay, we're going to show the hydrolysis, how the hydrolysis is going to occur, which is basically using water molecule. Let's show that. Ideally, HCl, hydronium ions, basically. But we're just going to be using H2O. We can use H3O plus or water molecule with hydrochloric acid. But I think this should suffice the way that I'm going to show the mechanism with using water. So let's just show that. And let's show the final product it's going to look like. Sulfadiazine, of course. Now we're going to show the step-by-step mechanism involved. Let's move this a little bit upward and show the step-by-step mechanism involved. Copy water molecule. So one of the electron pairs on top of the oxygen, or basically basically the ketone here, or the amide here in this case, is going to grab the one of the hydrogen and the water molecule. Well, instead of using water molecule, it makes more sense to use hydronium ions, but which is H3O plus, so that so that the oxygen atom is more likely to grab one of the hydrogen. Let's do that instead. Instead of having the water molecule, just water molecule, we're going to have this as hydronium ions, so that the oxygen atom here is more likely to grab a hydrogen from the water molecule. Let's show that instead. Okay, let's do this. H3O plus. Let's remove. H3O plus, hydronium ion. Copy. Paste. Let's also remove this. Okay, the oxygen atom here is going to grab one of the hydrogen from basically the hydronium ion, turning this into a water molecule. Okay, let's show what we're going to end up with. Copy and paste. So we're going to end up with something looking like this. Plus with a positive charge here. And with H2O. H2O. Let's draw it another way so that we can see the mechanism clearly. Adding the hydrogens, let's add the hydrogens on the water molecule. Move this down a little bit. So what we're going to have is that the water molecule is going to attack the carbonyl carbon, which is then going to break this double bond here into a single bond, sending the electron pairs onto the oxygen atom. Let's see. Okay. Show what this is going to actually look like. Okay, let's not forget to include the other hydrogen atom that's on the uh, oxygen here. Let's just show it. There's a positive charge here. Hydrogen and hydrogen. Okay, let's show the byproduct. Take a copy of this. Let's also add the electron pairs. Once this happened, once the water molecule attacked the carbon on carbon, a an additional water molecule is going to grab a hydrogen from this, from the positive charge here. Let's show that. Let's show the hydrogen before the covalent bond is formed. Before the double bond is formed, another water molecule is going to grab a hydrogen from this water molecule. Let's show that. Let's also add the hydrogen atoms on the water molecules. Okay, so what we're going to end up with, we're going to end up with this. And of course, H3O plus as well. Let's take a copy of this. Copy, paste. So yes, the nitrogen here is going to grab the hydrogen, which then the covalent bond is going to break, sending the electron pairs on the oxygen atom. Let's show the final product, which is going to be the sulfadiazine, and as well as with the carboxylic acid and hydrochloric acid on the other side, on another page. Yes. So with this as the sulfadiazine, let's write that down, sulfadiazine, and this as the carboxylic acid. And the hydronium ion, which is H3O plus. Okay, so once again, thank you for watching.